I think there's one disclaimer I would like to give. I have not made the presentation, as in I intend to have this presentation more of a more using the command of the console rather than using any PPT, because I think it's these kind of presentations are better suited when explained using live examples. So that's why I haven't purposely gone into presentation mode. But yes, a few guidelines that you can mute yourself unless you are talking. And if you want to ask any questions, you could type your questions in the chat box. And yeah, that's it. So hello everyone. Welcome to the 8th session of this series, Introduction to Common Compiler Tools. So basically today we are planning to explore these two popular debuggers, LLDB and GDB. And I request 60 minutes of your time so that we can go over and get a new perspective towards how to use LLDB and GDB, and maybe we could convince ourselves to use LLDB for most of the cases. So there's one point which I wanted to highlight. I was going through a lot of tutorials on YouTube, but it seemed that there is no such video where both LLDB and GDB are kind of covered together in a video. So I think this will serve that purpose. And for the presentation itself, I'm only considering C++ programs, and the environment is Ubuntu. So before going further, I would like to highlight about me. So I am currently working at NVIDIA in the compiler team, and my journey in the corporate world started with NVIDIA. So I was doing an internship there, and then now I've completed around 3 years with as a full-time employee here. So one of the challenges that I faced when I joined NVIDIA was dealing with large code bases. I was new to that, but one friend who helped me throughout this process was debugging. And I'm glad that I can share I can present this talk with to all of you. And I hope we can make the best of it. In fact, I would like to share a note that this session plans to take you from the basic commands and basic utilities to the best of I know. I don't plan to cover everything here, and I think it should not be really required, because this video itself, I feel, can help you, can serve as a starting point, and we could figure out the rest of the things. And I also feel that it's important to highlight the concept and science a little bit and just not really focus on the trick and technologies. So now I come to the content. What is debugging? I don't have a formal definition for it, but what I personally realized is that it helps you understand the state of a process at a particular time, and also helps you understand how the code is executed. So in short, I would say that it helps you understand the data flows and the control flows. And if you have any points to add, you could also unmute yourself and add. So we could make it interactive. The reason for debugging, I'm sure we all know this, but just for completeness, I would say that it's to fix bugs, but it is also to understand code which you have not written, or maybe want to reverse engineer something. Having said that, I would like to highlight 3 kinds of debugging, which I have come across in my life till now. The first one I have used a lot in my college, which is print statement. So basically, write a print statement in the code and see what is the value of the variable, let's say. I was reading online, it says that it's also known as adding trace code to your program. But this kind of debugging method is not really scalable, because you need to, of course, clean up the code that you have introduced. And the second point is that second type of debugging is using debug logs. So those who have worked on LLVM or any such big applications, they know that debug logs are very, very useful for everyone. And the major drawback here could be that it takes efforts to build this support. And of course, you have lesser information of the control flow of the program. So in order to, execute the program the way you want, as in stop whenever you want and inspect the variables there, uh, we have interactive debugger, and LLDB and GDB are types of the interactive debugger. So yeah, it lets you perform both source level and ASM level debugging. So if you want to debug it through using the source code, like say your program is in C++, you can either debug using C++, or you could also kind of inspect the ASM code which is getting executed. So interactive debuggers, we have around, I would like to actually mention three famous debuggers. So we have GDB, we have LLDB, and we have Visual Studio's Windows Debugger. So I started my journey using Visual Studios, and it has been very helpful because I think the interface is quite actually nice. It helps you understand the whole code very nicely when you have multiple files. That's what my personal experience has been. But the motivation behind getting familiar with GDB and LLDB, in my opinion, is that sometimes our applications are more suited, or they are built keeping the Linux environment in mind. And even if they have a Windows support, they are a bit heavier. And so if you are using GDB and LLDB, the turnaround time is faster than using a Visual Studio's Windows debugger. So currently, GDB and LLDB, apart from C++ and C, they kind of support more languages, but I am only restricted to C++. And maybe I can highlight that on Linux, by default, you will have GDB. Now, interestingly, when I was on WSL, I didn't have GDB by default. I had to install it, and I could actually show how I could install it in the next slide. And on Mac OS, you will have LLDB by default, and Visual Studio will be default when, if you're using Visual Studio, then of course the default would be Visual Studio's Windows Debugger. Okay, so the next I wanted to highlight is the agenda for the complete session. So I've completed the first point, which is just a basic introduction to debugging. From here onwards, I plan to use the command prompt more often. So let's get to the context. Okay. Fine. Okay. So setting up LLDB and GDB. I have already installed LLDB and GDB, so I will not be showing that. But these are the two commands that I had used to install GDB and LLDB. And I was facing this warning, sort of. So this fix to how you could fix that has been, I have kept a link here, attached a link here which you could refer and just fix the code. Basically, it's trying to search for the Python binaries, but the Python binaries which it is searching for is present at a different location. So you need to set the Python path environment variable to the correct Python binary location, and then you will not get this anymore. So let's get to the interesting part. How does your code compile for GDB and LLDB? So okay. So I have written a very small code. I'm currently on. I request you to currently focus on the console screen. Is it fine? I mean, is it too small for all of you or big? You could confirm that.
It's fine, I think.
It's fine. Okay, thanks.
At least for me, yeah.
Okay, okay. If anyone finds it too small, let me know. I will try to fix it. Okay. So yeah, it's just trying. It's doing a basic arithmetic and trying to print it. That's not really the intent of this function. Intent of this C++ program. So what I plan to do is that um, G++, then the test demo.gcpp, and this minus G is the command argument that you should be putting so that debugging information is embedded into the executable. So I can show one thing, demo, uh, um, okay. So I will also compile without minus G, and there's something I would like to show. So there's the file command where we can actually verify that it has the debug information. So you could see this, right, with debug info. And if I do file demo without, so the debug info is not present. For example, I try to run this, um, pass this demo without to GDB. So it will give me a warning sort of as well, which is no debugging symbols found in this. And it's not really useful to kind of execute because there is nothing like you can't really get anything. It will just execute and you can't get access to the source code. So you could also inspect the contents of um, this execute binary with using obj dump, and it prints a lot of information which I will not cover here. But what I can cover is that minus G command basically is telling your compiler to embed the debugging information. So by debugging information, I would mean that proper names of variables, function names, line numbers, then the source code. So basically, whatever source code you see and ASM code you see, the names of variables you see, that's because minus G command is doing something to kind of embed this information. It's invoking code which embeds this kind of information. Okay. So I'm going to the next slide, which is about types of errors. I think we can use the symbolic. These are few of the cases where I think we could use the symbolic debuggers. So I have divided it into two processes. First is a crashed process, and the second one is value mismatch. Uh, this is basically whatever I have come in my software journey, software engineer journey till now. I've posted that here. If you have come across some interesting, more things, more applications, you could share. So let me actually talk about or maybe show example of assert. Okay. Mm. So by crash process, I mean that your process will crash if let's say you access. It can crash due to multiple reasons. One of them is assert. Second one is abort. Then you can have segmentation fault where you are trying to access a memory which is not present, or it should not be accessed. Then you can get into you can run into an infinite loop. You can come across leak, and you could also have exceptions. So, for example, I can demo assert.cpp. So this is a very basic example that I have written where this code will assert. it's sure to assert because this will this condition will turn out to be false. The resulting condition will turn out to be false because name is null. Okay. So G plus plus minus G assert dot CPP minus O assert dot O. Okay. And let's say I try to run this. So what you see is this has been aborted. And I'd like to highlight one point here is that assert is widely used in big applications, as in the compiler I have seen that stream LLVM, if you see, you will see many instances of assert. We will have a look at some of these examples and we will use to debug further. So let's get to another part where I'm going to spend most of the time. So some of the useful actions in GDB or LLDB is, in my opinion, is this, and let's cover one by one. So first is launching. So for this, I will actually take this example. I have written a bubble sort. Basically, it's a basic bubble sort example which I have written, and let me just compile this. So let's say I want to launch this. So at the moment, I don't have any command line arguments to be passed to this, but for example, when you are debugging any program which has a lot of command with which you have to pass command arguments, you should be invoking it this way. So you should use a hyphen and then whatever your command arguments are. But if you don't have any command arguments, you could exclude this minus hyphen. One more thing I would like to highlight is that for these basic commands, I intend to use LLDB mode, but I've also listed what is the GDB alternative in GDB. So I hope that would be helpful. Okay, so I don't have the any arguments here, but if you want to show any arguments, then you could use settings show uh, run target run args, but there are none here. So before running the program, I think I would like to highlight how you can stop your code at certain program points. So whenever you want to stop your programs using a particular program point, you must be making use of breakpoints. And let's. So okay, I did not really show the code. Just I will show the code first. I have the code open. So it has three functions. First is the function which is doing bubble sort. The second is the function which is doing print, which is printing the array. So I hope this will be helpful in visualizing the frames as well. Since we will have multiple frames, so we could actually see multiple frames in the output. Anyways, I just start again. So the first thing is I would like to put a breakpoint at a function. So let me put a breakpoint at main. And I will, in order to run the program, I will use the command R. So here is the major difference between GDB and LLDB in my opinion. The first major difference, it is that in GDB, you don't get to see this kind of an output. Basically, you don't see you see only the code, the line which is getting executed currently, not the code beyond it, like around it. So that's why I have used LLDB for showing, for demonstrating these commands. Okay. So it has started. It is now basically stopped at the first line in the main function. But let's say I want to use the. Let's say you have a application where you have multiple C++ files. So you would want to use um, a C++ file to create the breakpoint. So let's say I want to break in this file only, but at let's say line number 22. So I have created that breakpoint. Now I want to check how many breakpoints I have and what's the status of it, how many times it has been executed. For that, I will be using the command brl. Okay, so fine. I can see that it has been the hit count has been for the breakpoint one, which is which we had already hit some time back. The hit count is 1, and for breakpoint 2, the hit count is still 0. So what I would want to do is I want to go to the next breakpoint. For that, I'm going to use the command continue, and I can come to bubble sort, which was my second breakpoint. But let's say I want to create one more breakpoint, and that should be a conditional one. I can use this example. So break, and I want to do this in bubble sort. So bubble sort function. So it's this kind of, meanwhile I'm writing the command, this is helpful, right? I just wanted to know that you are able to understand the commands what I'm running, or
Hey, sorry, I have a question.
hmm.
Can I? Yeah. So this file base that you mentioned, right? So can we use this to put breakpoints in multiple files, right? So like we'd use like headers and like link other files
Hmm.
as well, right? So can we use this for
Hmm.
that as well?
This whatever I'm showing right now, yes, exactly. That's the point I was trying to highlight. You can use this to. So what I do personally is that I use the file name, and I have the line number, and I can either make it conditional or I just put a breakpoint there to inspect things. So this is very useful when you have multiple C++ files and basically you're working on a project.
Yeah.
Does that
Okay.
answer?
Yeah. Thanks.
Okay. Okay. Fine. So uh, next is, what I want to do is that I will put a condition here. So okay, I'm going to use this point. So break S stands for set, minus F stands for file. So file here is my bubble sort dot cpp. Then line number that I want to highlight here is 7. Basically, I want to stop at this point when my j is, let's say, 2. So that's why it is L is 7, and uh, L is 7, and condition is j equal 2. So again, I can have a look at the breakpoints. So you could see that the condition now has been, there is a condition which is attached to this breakpoint and it is j equal to. So let me continue. Now what I am going to, okay, so before I go further, I could just get to the presentation and highlight some more things. So when I'm doing BRL, I can get to, apart from the point that I get to know how many times it has been hit, I can also get to know how many times it has been ignored. So this is again an interesting feature which I want to explore in the, which I will explore further now. Now, if you want to delete a breakpoint, you can delete it using this command on LLDB and so what is one? One is the ID that you could see. So this is the first breakpoint, this is the second breakpoint, and this is the third breakpoint. So if I do br del 1, then it will be deleting the first breakpoint. I can disable it also, and I can enable it back again using these kinds of commands. And next is I want to skip the breakpoints. So I will skip the breakpoint for, let's say, um, once. I can, let me try to do it, try to do this once. So the first argument here is the ignore count, and the second argument that you see here is the breakpoint number. Okay. So currently what I will do is I will modify the breakpoint, and I want to modify the breakpoint number 3, and I want to, let's say, ignore it twice. Again, I will list the breakpoint, and I can see that ignore 2 is coming up. Okay, so I will continue again. Okay, it has exited. Okay, my bad then. I kind of, okay. So I'll just put a breakpoint here. Okay. So this is the breakpoint, and I would, let's say, ignore it for 1. And I will continue. I will run and, okay. Fine. Okay. I think I just messed it up. I will pull out other program just a minute. So there is a bubble sort infinite, which I would like to probably highlight. So so since I don't have any command arguments, I'm just using directly calling it like this, LLDB bubble.o. Okay. So I'll put a breakpoint at like this. And I will modify this now. And let me run. Okay. So one thing that I wanted to print here is the I. So I is 12 here, and I would also like to um, show that it has been hit 4 times here till now. So we can now go to the next slide. Anyone has any questions here? I think skipping the breakpoints is an interesting thing in my opinion, and we could use that. And conditional breakpoints are also quite interesting. If no questions, then maybe we can go to the next slide. So similar to breakpoints, where we can basically stop at a particular program point, we have watch point, which are basically set on variables and expressions, basically data. And yes, one thing one must understand, that you can only set it after the process has started executing. So let me then start with this. So similar to breakpoints, you can list the watch points also, and you can delete the watch points using this kind of commands. And you could also modify the watch points. And for example, I'm trying to add a condition here. So I want to set the breakpoint on I, and you might be interested to know what is the code. So so I'm currently at line number 80, and what I am watching is the variable I. And I want to set a watch on it. And you could see this, that this is, so it prints, one interesting thing is that it prints the new value, and it also prints the old value. So for example, I want to again stop when my value is 14. Let's say I value when it is 14, I would like to stop, and I will first understand, see how it is, what is the output of watch L, which means that, yeah, this is similar to breakpoint, just that it's more oriented towards the data, and I will continue. So this is watch point hit. The old value was 12 and the new value is 14. And since the value of I changed, or it has been accessed, so that's why we are basically hitting, we are stopping, the code execution is stopping at this point. So this has been helpful, right? Um, then next is that we have now understood how you can stop at particular points in the code. It might be more interesting to understand how you can, run each code one by one, each line one by one, as in. So I would like to first start with frame. Basically, we all know that when you are calling functions, a new frame is created. Basically, each function can be considered as a frame, and whenever you are calling each function, a new frame is created. And that's why you would see that in debugging, you are traversing through frames and trying to understand the what all variables are live at this frame. So if I want to see the information of whatever variables are live at this point and in the current frame, then it should be frame and select. Oh, not very, sorry. Okay, so if I want to see which code point I am at right now, so it should be visible using frame select. And if I want to know how many, like what is the state of the variables at this point, whatever values are present in the variables, I will use frame info. No, I will not use frame info again. Okay, sorry. I'll get to know what is the, okay, I apologize for this. So I'll get to know which frame I am in right now. That's it. I think I was jumping to the next slide. So frame basically gives you the information that what is the current source line and what is your current frame. If you want to know what all frames, what is the backtrace, then you can use bt command, and you will get a basically a dump of all the functions which have been called. So I can, if I look at my source code and my backtrace, then I can see that it is, I have three functions. One is sort, one is print, and one is main. So how am I calling it? I'm calling the sort first. First main is invoked, then sort, and then print. So I can see that. Currently I'm at sort, so the caller here is main. That information I get. And if I want to see only the last first two frames of the current thread, then I should be using BT2. Okay. So let's say I want to again know what is the source code. So for example, I want to get to the next line, then I will use next. And if I want to get out of the current frame, then I will then I will get into, I'll type finish. Okay, so it has again, it's again calling here. So what I will do is I will go to, let's say I want to avoid executing next, and I want to directly go to the 16th line. So I have a beautiful command here which is thread until 16. 16 is the line number I want to go here. So I don't know what has happened. I think it has happened. Okay, I think it has happened. Just a minute. I'll have to do again. Sorry for the glitch. It has been hanging for some time. Okay, so maybe I can just do one thing again. I can put a breakpoint here, which is, let's say I want to do this. Okay, and this is, okay, so this is an interesting error. This error was intended. So I get a stack smashing detected error because this code actually gets into an infinite loop, and what happens is that when you have exceeded the buffer size, that time you get this kind of an error, and I don't intend to debug this. I would rather debug this one. Okay, so break main, and I will run. Okay, so let's say I want to now go to this point. Then I want to basically start. I want to go to bubble sort. So until 22 is what I would do. No. Okay. So I'm here at bubble sort and this line, and what I want to do is I want to step into the current into this code, into this function. So I will use S, and I am into this frame. And if I want to get out of here, I will use a finish, and I'm again back to the code. to the main function. So that's what I wanted to show from execution point of view. Any questions?
Yeah, I had
So,
one question.
mm-hmm.
Yeah. So you mentioned that we can step into the function as well, right?
Mm-hmm.
So
Yes.
sometimes we might call a different function, and whatever it's returning, we just directly pass into a new function, right? So how do we
Mm.
choose between those two functions?
So I don't get this point. I mean, how? So basically, let's say you are you is it by mistake you get into printf and then you want to just get out of it, then you use the finish. So that's how you exit of that frame. So you consider your function call as a frame. To get into the frame, you use the s command, and to get out of the frame, you use what's say finish.
Uh,
Is that
Sorry if
what
I
you are
was on.
expecting? Hmm.
No, no, no. For this particular example, let's say bubble sort brackets
Mm-hmm.
get some array. Then there is a function called get some array comma n, and then the bracket is complete for bubble sort. So you're calling a function within a function, like giving that
Mm-hmm.
return output to as a parameter to a new function, right? So how do we
Mm-hmm.
select between the outer function or the inner, since on single line there will be multiple functions being called, right?
Right. I get the point now. So in that case, what I do is if I want to enter into a particular function, I particularly put a breakpoint, a conditional breakpoint, or rather a breakpoint for that particular function. What will happen is that you're calling, let's say, foo, and inside that you're calling bar. So first of all, bar will get executed, and then only once bar is computed, foo will be executed, right? So if you have by mistake got into bar and you didn't want to really execute the bar, what you would do is you can just step out. That's what I would do.
Okay, thank you.
Uh, what I think, yeah, that's what I would do. Okay. If anyone has other answers, you could share. You're free to share. We could make this interactive because it's more of a demo presentation. I could not really think of having screenshots on the screen. I felt that it's better to just kind of show the live demo. Okay. So the next is that you're interested to print or rather understand the value of the variables. So I was initially, if you remember, I was trying to print all the variables which are live in that frame, and I basically wanted to use this command, which is frv, show all the arguments in the current frame. So it prints. I have two kind of variables here. One is arr, and another one is n. So if you see that ARR is now sorted because we have already invoked the bubble sort. But let's say I want to print an array. If I so here, okay, let me do one thing. Mm. So break, I would like to do it in. I want to show you one thing, which is I will break into bubble sort, and I will run. Okay. Uh, I'll not use this. I'll use another. Uh, so I want to break into sort. Okay. So I request your attention at this point. this main function, it is basically it's populating the array, and it is invoking two functions, sort and print. So to sort, it is passing a pointer. It's not an array. Sometime back, I did show how I can, if I just do frb, then I am able to print the array nicely. But in this case, if I, let's say, do frv, what I will get is I'll get the address of array, or basically the contents of array, and I'll get the value of I and the value of false. So if I want to know what is the array basically looks like, then I can use this command, which is p of array. Let's say I want to print only the first 10 elements of the array. So this is how it would be looking like. I believe this is a useful command utility, because it helps you understand what's the contents, what is the content of an array if you're just given the pointer to it. Okay, let me do frame select, because I don't know which code I am, what's the source line. Okay, so now I can see this pool sorted. What I want to do is I want to print some of the variables. So I can do b of array, b of I. So there are three functions which I have, three command which I've listed. One is p, second one is po, and the third one is v. So how are these three things different? So if you are aware of expr, then p is basically the alias of expr. I'm sure most of you would have used po, but p and po basically they take the source command, whatever source command you are giving to the source argument, whatever you are giving to the command, it will take that and it will execute it and it will output it to the console. So it can execute anything which is within the scope of which is within the scope. For example, I'm doing a very basic thing like I plus 10. So it will print 10 because currently I is 0. And similarly, I could do I plus 11, it will be printing 11. What you can see here is that the way prints the output is different. So here it will be using, what do I say, LLDB. This is basically LLDB's convention of naming the variables. I've mentioned it here. And PO will basically print it this way. It will just print the value, but P will be printing it. Uh, it will use the LLDB convention of the variables. The P is useful when you want to do any type of dynamic, you want to do dynamic type resolution. And if you want to know the example, I have put a reference here, and we could go through that. I don't have an example right now, but yeah, this has an example and you could go through it. I will go to the, okay, I think I'll go to the next slide now. So one thing I realized is that I am, whenever I want to debug something, I would be also interested to see the, along with the source code, I would also like to see the ASM code. So if you want to see the ASM code, you could use this. I'm just copy pasting things. So I'm copy pasting things from a website, which is the LLDB official website. And there is this interesting page, which is GDB to LLDB command map. And it has a lot of things which I could not cover due to time constraint. One of the things was this one. Okay. Target stop hook add. So what I will do is I want to disassemble the code. I want to get access to the source as in code whenever I am executing through the code. Okay, so I am done. Okay, so let me go to next. Can you see this? Now I'm printing the ASM code as well. You could see that, right? And I can also see this underscore, which is to 0, which is equal to. Okay, and let's say I want to instead of iterating through the source code, which is this one, I'm interested to execute the basically run through the Azure code. So the commands that I will be using is step I and next I. Step I is similar to step. Basically, you step into a function, and next I is similar to next, and you want to continue. You want to go to the next line. So if I go, so you will see that I have come to this point, but the source code is still at 4. Okay, I think I just be a little faster. So this is what I wanted to highlight. Let's say I want to also understand what is the register values here. In, so in order to read all the general purpose registers, then I will do register read, and I can see all the general purpose registers values here. If I want to get access to all types of registers, including let's say floating point registers, then I will do register read all. So I get access to a lot of things. Now let me just get to the interesting part. I want to, let's say, skip only 8 bytes. This is the current program value, and I want to skip only 8 bytes ahead. So what I can do is I can use this command, and it will just uh, show me. It will just go further 8 bytes. Okay. Maybe I can cover the text visual interface first, and in interest of time, I think yeah, I would have expected a little more time. But anyways, anyone has any questions right now? If not, then I can just
I had
get
a small
further.
question.
Hmm.
Um, so I guess a while ago you mentioned how you could see the contents of an array passed at a passed as a
Hmm.
pointer, and because it was
Hmm.
C style array, it did not have a fixed size or something, so you could access any random element in that. So I was just wondering if I could, using the same command, if I could see the contents of the memory inside the buffer. Um, Suppose if I were to point an integer array, integer pointer, and then
Hmm.
execute the same command, let's say I pass in an argument of 10, so that I can see 10 spaces into the memory. So would it show me any garbage data present in the buffer?
Hmm. Uh, I think if you want to look at, I am not sure of that. I haven't tried it. Maybe I could try that and get back. I just tried it for this kind of a thing. Not really for.
Sure, that was something that came up in my mind. I'll be sure to try it too.
Hmm. Yeah, we could try it actually, but maybe I can. If we have time towards the end, we could try write a small program and just try it out. So maybe that could be one of the use case.
Sure, sure, sure.
Okay.
I guess we're running low on time.
Yeah,
Yeah.
yeah, that's the point. Okay, so maybe I can
Also,
do one thing. Yes.
sorry, yeah. Also, a follow-up question to that, the previous one. So, if you have a pointer to some pointer, can we like trace back and then find the data wherever it is pointing? I mean, trace back the chain of pointers.
trace back the chain of pointers. I think I got to try those. I can't really tell on the spot because I didn't really try them.
You
I
can
think
keep
these are
on.
interesting.
You can try keep on reading the addresses and then follow each of the address one by one.
You can also put a expression there with print command. So if you want to go multiple level deep down, you can have multiple stars there, and the you can go
Yeah.
pointer to pointer or even any level. So the expression doesn't need to be
Let's
something.
try. Please continue.
Yeah, I was just saying that the expression doesn't need to be necessarily from your source program. So you can construct an expression there, as I think you demonstrated
Yeah,
something
yeah,
like
yeah,
plus 10 or whatever. So something
yeah,
similar.
yeah. So if I want to, okay, there was this P array, right? P array, and okay, maybe you want to start with just P of star array. You would expect something like this. Yeah, it does show some value, but I am not sure it's. A, I don't think it would be garbage, but yeah, it would be showing the address of array here, and no, it will be showing value inside that.
So it's showing the first value of the array. Star array points to the 1st array 0.
Yeah, right. Yes.
You should be
We
able to
could.
print arbitrary value with the square bracket also, I think.
Yeah.
Yeah, I think that's correct. Yeah. Let's say if I try to print 31, I guess I should get some value on top of value. Because the array size is of 31 here, and I'm trying to print 32nd element as well. So right, star array is the first element, and yeah, maybe I can. Does that help answer the question? And thanks for the inputs, by the way. I probably can just cover the text visual interface TUI. I think maybe you would be knowing it, but this was something I feel it's quite helpful. So I think like TUI enable we have, and it kind of enables me. No, I mean it kind of enables the TUI, and what I can do is I can just show layout source. Layout source is already getting shown, but layout split, which is I'll also get to see the as right, and you have focus, which is let's say you want to focus on source, so you're already focusing on source. We want to focus on ASM, we could be focusing on ASM. I would, let's say, start with main, and you could see that basically you can see, right, we could see the source code and the ASM code together. And I covered few slides back that you can have next I to go to the next line in the ASM code, and yeah, you can actually uh, go to the, let's say you want to step into the code, and you could basically step here. Okay, so yeah, that's what I wanted to show here. And if you want to disable the TUI, you could do that. So my my point is that if you want to use text visual interface, in my opinion, GDB is better. If you want to use, otherwise, if you want to just play around in the command line with the command line, then in my opinion, LLDB is good just because you get to see the, in my opinion, because you get to see the source code to some extent. And what I have realized is that the GUI for LLDB is not very well advanced like TUI. So this is very helpful when you want to show, when you don't know the complete code and you want to kind of get access to it and want to see how the code flow is happening, the code execution is happening. I think I have exceeded time. Maybe I can highlight just one point here. If you have any questions, actually we can pause for questions here right now. I will just show some tiny things that I have. No questions. I think we got some good questions today, and but if you have more questions, you could ask actually.
Hi, I've started my journey as a compiler engineer a few months back. So I have a question that can I able to debug the custom written passes in LLVM? Is there any option for it?
Custom return passes in LLVM.
You can use.
So-
You can try building the compiler in debug mode and try setting the breakpoints on the initializer of your custom pass, and you can then step through your the pass.
So where can I find it? Like in VS Code? Like I'm basically using VS Code. So where can I find it over there?
I'm not sure about VS Code. I mean, about it.
So
I'm not sure what. Sorry, just a little point. I'm not sure what Rex is asking about, but there are few GitHub repositories that refer to that particular statement of your question. You can maybe refer to those.
Okay, I'll just check on it.
Okay. So one interesting thing that I came across is the last one. Maybe I'll not go further. So I used to in my code when I was debugging in my back in my office, I used to see segmentation faults, and there was this aborted code dump. I always used to wonder what it is. Maybe if you would, maybe you would be knowing, but just for completeness, I wanted to highlight this that a core is dumped, which has the complete processes memory. It will have the stack frame and the what was the value of the variables like at that point. And in my opinion, that's useful when it's when the error is hard to reproduce, and or when it takes a lot of time to reach the crashing state. So there's so how do you basically enable to basically currently I don't see any code file. I came across a seg fault, but I don't see a code file. That's because I have not enabled to generate the code file. I've set the size to 0. I have to increase the. I can do it to like unlimited, so that it can generate code files. And after that, when I would be running the code file, it would be when I'll be running the binary, I will see a code file dumped. And yeah, if I want to, let's say, debug using the code file, then it would be okay, segfault.o code and then oh. So okay, I don't know what's happening. Yeah. So this is where I am. You might be interested to see what is the code. So this is the last one that I wanted to highlight because I kind of exceeded the time. Is there anything else you would like to add here? Any feedback, anything? So what I was trying to do is I have this null, the pointer is set to null and I'm trying to access it. So that's why it's giving a segmentation fault. And when I'm just doing frame select, it shows me where did the code actually fail. So that's what I wanted to highlight here. I have skipped a couple of things this time. I was also planning to cover how you could integrate LLDB or GDB using VS Code. And yeah, I think I didn't cover that. But maybe the ending point could be that you can introduce GDB and LLDB, as in, let's say, in this whole presentation, I have used G++ to generate the debug symbol, to generate the binaries. So for debugging those binaries, I have used both LLDB and GDB, and that's because the binaries are in ELF format. So yes, actually, they can process it basically. But what I have read online and I have been also doing that is if my project is built using GCC, I have used GDB, and when my project was built using LLVM, I have used LLDB. So if anyone has a varied opinion, they could please share. But that's my personal point I wanted to share. And this is a small table that I wanted to also highlight that if you are, in my opinion, if you are doing command line debugging, then LLDB, I would prefer LLDB because it gives a more structured output. No, because the this command arguments now, these are structured in my opinion, and which is not the case with GDB, and also it shows the source code, glimpse of source code while debugging. So that's very useful for me when I know the code to a certain extent. And if I want to use TUI, of course, I will use GDB here, and I get access to ASM also here. I have exceeded time this time, and I'm thankful to those who have had the patience with me to stay up till here. And if you want to get updated with the LLVM project, and as in all the presentations we have covered this, so I'll just cover here for completeness. You have LLVM weekly. This is very interesting because it gives you a glimpse of all the projects, and I personally learn a lot from it. And LLVM YouTube page also I kind of follow. And along with that, I could request you to also keep a track of LLVM Social Bangalore meetup page because all these sessions are recorded and posted there. And I hope that the commands which I have shared, they would be helpful for you to debug. I personally learned a lot of things while preparing this presentation. So maybe I will pause here. If anyone wants to share their experience or ask any questions, please do so. Okay, so yes, for integration with GDP. So I did not set this up. This is my personal laptop, so I could not really set up the Visual Code. I wanted VS Code for this. I wanted to do that, but I think there has been some communication here. You could refer to this. Maybe I am not be able to cover it now, but yeah, point to be covered in the future. So I have nothing more to share here. You have any questions or any feedback, anything? I would have covered this, but yeah, it's now late. Mm, If we don't have questions, maybe we could end. And we have a WhatsApp group. Um, we have a WhatsApp group. Can Pradeep or Ashutosh please share it? I could not take the questions, but was it answered? Yeah. There's one point which I wanted to share. If I mean, this is not related to LLDB, but I was trying to build LLVM on my personal system. So I tried it using WSL, and it has taken it hasn't taken a lot of space. I don't know if that's the it takes a lot more space than the normal without the debug build. But yes, it has been interesting. I mean, to set it up. It didn't take a lot of space on my system at least.
Yeah, just a small question. I'm not
Mm-hmm.
sure if this is relevant to LLDB specifically,
Mm-hmm.
but does
Mm-hmm.
LLDB support capability to like go back the execution? I mean, undo the execution of some commands. Like we went from line 16 to line 18. So can we go back to line 17, like just undo it?
Okay. Okay. I like so there's one thing which you could do. You could what you are talking about is reverse debugging. So it's possible in GDB at least. I have seen um, presentations on that, and in LDB I think it is possible probably. But I'm not sure of LLDB as such. But GDB, it is possible. You basically have to record it, and then you have to kind of you can use these kind of commands. I have not tried that personally because I didn't have to uh, use it in my life till now. But yes, reverse debugging is possible, and it's useful in cases where, let's say, yeah, you have reached so you have some buffer flow overflows kind of you've encountered a buffer flow overflow issue, and then you would want to see what went wrong, so it's useful for debugging. I know I can
Thank,
only answer that yes, it's possible. Reverse debugging is possible. You could go up.
thank you for answering that.
Mhm. Thanks for asking the question. Another bit info. Yes, yes. So LLVM debugs. So this is what I was referring to. Debug logs. By debug logs, I meant LLVM. These kind of print statements. I don't have a example here to show. The reason is this is my personal laptop and I don't have LLC set yet. But yes, we do have a lot of such examples. And this is very helpful. I have learned a lot about the IR. I would share that I have learned a lot about the IR using these LLVM debugs. Discord server. So this doesn't has a Discord channel. This particular group which you are a part of only has um, a WhatsApp group, but this is the Discord server, and you will get the link to. You'll get this slide text just after this. If no one is talking, I can talk. Can we end? Otherwise, maybe I can just highlight one point here again. So we mentioned a lot about the frames, right? So basically, whenever your code is, whenever you go from one function to another, you create a frame for each of the functions, and what happens is when you do a context switch from one function to another, the state of that function, the caller function, is saved on the stack, and that is, you get the address of it using, if I'm not wrong, a frame pointer, which is the end of the last frame, and using the stack pointer, you will basically, whatever variables are live right now, or whatever variables are getting populated, they will get pushed onto the stack, and your frame pointer, stack pointer will kind of decrementing because your stack grows downwards. And this is because, and this layout, whatever you see here, it's basically, you can consider that a process um, uh, is basically access. It has this kind of a memory, and it is assigned a particular chunk of physical memory by the kernel, and but the process thinks that it has the whole memory available to it. So what happens is that whatever you see, the addresses that you see in the presentation, or in any of your experiments, you would see that they are all virtual addresses, because this is converted from they are not really real addresses. The memory management unit basically, for any IO, if you're reading to the memory, reading from the memory, then you basically convert your virtual memory to physical memory. So that was one point I wanted to highlight. In fact, I would request all of you to go through, if you have time and you're interested in memory layout, then you can go to this site. This is very, very nice. I felt it's very good. So you could go through that. All the references are on this.
Just adding on one more question regarding frames and threads. So in parallel threads, how do we toggle between like thread 1 or thread n? I mean, going back and forth.
Right. You asked a nice question. I had skipped this one. So this is also mentioned. This link I have attached it on this presentation. I just pointed out. I have not tried myself. Just a minute. It was here. Sorry. Okay. It's somewhere here. Yep, I got it. So if you want to examine thread state, these are the kind of commands that you will have to use. So I used actually BT on, and it will show me the backtrace of all the threads. But if you want to show only the backtrace for the current thread, you use BT. And let's say if you want to, I think, select a different stack frame, then you could probably use this one. I was using just frame select, maybe you could use this one. So I've not tried it, but yeah, this is the section which you should be looking for. It's possible to switch between threads while debugging.